hydrolysis of salt of stronger base and weaker acid. When this kind of salt is taken, how the hydrolysis takes place? That is explained as follows. Yes, we can take a weaker acid. It's the best example of weaker acid, CH3COOH. Aqueous, when it is in contact with a stronger base like sodium hydroxide in the aqueous medium, what happens? The H plus can combine with OH to form H2O, so that we will be getting CH3COONA, sodium salt of that, plus H2O. In this way the salt is formed. So sodium acetate is the best example of the salt obtained from the stronger base and weaker acid, sodium acetate. The sodium acetate is now taken, CH3COONA, in water. It would be dissociated to form CH3COO minus and Na plus. Yes, either we can take the aqueous solution of sodium acetate, and you need not mention this water. It is dissociated to form acetate and then Na plus. And water is dissociated to form H plus and OH minus. The solution, sodium acetate solution, in which these are the constituents: acetate ion, Na plus ion, and H plus is there, OH minus is there. The acetate, CH3COO minus, is the conjugate base of CH3COOH. We know that the acetic acid is weaker. Acid and this base, CH3COO minus, the conjugate base, is having a strong tendency to combine with the hydrogen plus ion, and it is forming CH3COOH. In the previous category we were seeing that NO3 minus was the conjugate base, not having the tendency to combine with the H plus. But at present, in this particular case, the acetate is having the strong tendency to combine with the H plus. And because the acetic acid is weakest acid, that's already partially dissociated. So it has got a strong tendency to combine with the H plus, and it is forming acetic acid. So considerably here, the concentration of hydrogen plus ion decreases as the hydrogen plus combines with acetate ion, and it is becoming CH3COOH. So what will be the consequence of this? Gradually, when the concentration of H plus is decreasing continuously, the solution can have the excess of OH minus ion. The concentration of hydroxide ion increases. This is increasing. And due to the increased concentration of OH minus, we can say hydroxide ion concentration would be greater than that of H plus ion concentration. Due to the same reason, this particular solution is becoming basic. The solution is basic, and its pH value would be greater than 7. So the salt of stronger base and weaker acid, while the hydrolysis, at the end of the hydrolysis, this is the best example, sodium acetate is forming acetate ion and Na plus ion. The smeared acetate is combining with the H plus to form acetic acid. So the concentration of H plus is continuously decreasing, and due to that the concentration of hydroxide would be greater. Due to the increased concentration of hydroxide ion, the solution becomes basic and its pH would be greater than 7. And we can relate the hydrolysis constant as well as dissociation constant of weaker acid as follows. Consider the sort of stronger base in weaker acid, and we were taken this example CH3COONA, the sodium acetate. Yes, when it is in contact with the water, what is happening? During its hydrolysis, we will be getting the following products: CH3COOH plus NaOH. Na is combining with the OH to form NaOH. So this is acetic acid, and other one is sodium hydroxide. Yes, the hydrolysis is over. Suppose if you want to calculate the hydrolysis constant KH, if you want to calculate, then how to calculate KH? KH for this is nothing but hydrolysis constant of the above given case is noted as follows: CH3COOH, and here I can take the OH minus alone divided by the concentration of acetate CH3COONA and the concentration of H2O. Try to understand, I have not taken this Na, what is appearing in the product side. Instead of this NaOH, I have taken the concentration of OH minus, hydroxide ion concentration. So the hydrolysis constant is now ready. While the hydrolysis, there may not be appreciable change in the concentration of water. So this particular equation can be rewritten as follows: KH, that is equal to the concentration of acetic acid into the concentration of hydroxide ion divided by the concentration of sodium acetate CH3COONA. So this can be taken as equation number 1, and we can discuss what happens when the acetic acid is dissociated. This is acetic acid, CH3COOH in the aqueous form getting dissociated to form CH3COO minus and then H plus. For this we can calculate the Ka, dissociation constant of weak acid. What's the purpose? The purpose is the hydrolysis constant KH is to be related with the dissociation constant, and to compare them and to relate them, this is essential. Acetic acid is dissociated to form acetate and then H plus, so that we can find a dissociation constant of this. It is nothing but CH3COO minus into H plus divided by CH3COOH. Yes, this equation in which if you ignore this Na need not be written, so it becomes acetate. And this is equation number 2. From equations 1 and 2, you consider this a KH and this one is Ka. Just multiply them, KH into Ka, which means equation 1 into 2. If you do so, then what will you get? You can say that the KH is nothing but CH3COOH into OH minus divided by CH3COO minus. It is to be multiplied by this one, CH3COO minus into H plus divided by CH3COOH. You see, the common terms can be cancelled. These are the common things. Acetate is getting cancer. Sorry, acetic acid is cancer. Acetate is also getting cancer. So this becomes, which is left there? The OH minus and then H plus. So we can have H plus into OH minus. We know the product of H plus into OH minus is nothing but ionic product of water, Kw. It means KH is multiplied by Ka, that becomes equal to ionic product of water. Ionic product of water is equal to the product of hydrolysis constant and dissociation constant. And with the help of this, yes, we can say that Ka into KH, that is equal to Kw, what we were obtained previously. Now, to calculate OH minus ion concentration by using the Oswald's dilution law, we were calculated based on the Oswald's dilution law. You have made one calculation, OH minus ion concentration, that is equal to the square root of Kb into C. Likewise, based on the same Oswald's dilution law, instead of using the dissociation constant of base, here the hydrolysis constant is to be employed. According to that, KH, that is equal to, I can say, H square into C. According to Oswald's dilution law, we know that Kb, that is equal to alpha square into C. Degree of dissociation, here the degree of hydrolysis and the hydrolysis constant. So if you use this expression, the hydroxide ion concentration, hydroxyl ion concentration, that is equal to the square root of hydrolysis constant into C. Yes, this is explained as follows. We know the Kb, that is equal to alpha square into C. Here the Kh, that is equal to H square into C. See the difference? This is degree of dissociation, this is degree of hydrolysis. This is dissociation constant of base, this is hydrolysis constant of this salt. And with the help of this hydrolysis constant of this particular salt, the hydroxide ion concentration, that is equal to the square root of Kh into C. Based on this, how to calculate the pH of this solution, pH of the salt solution in terms of Ka, that can be tried as follows. Yes, this is done. pH plus POH, that is equal to 14. Now we should find the pH of this particular salt. What kind of salt? The salt what is obtained from the stronger base and weaker acid. What is that salt? This is a salt, CH3COONA. For this we should find the pH. Directly pH cannot be calculated, but we can calculate the POH first of all. And how to get the pH, that is equal to 14 minus POH. We can write 14 minus POH is nothing but negative logarithm of hydroxide ion concentration. You see, what is the hydroxide ion concentration or hydroxyl ion concentration? According to this expression, it is nothing but the square root of Kh into C. So I can say minus logarithm of Kh into C the whole power half I can write, which means the square root. Okay. And this is written as follows, pH that is equal to 14 minus log of kH into C the whole power half, in which, what is this kH? kH is equal to, we can say, we already calculated that Ka into Kh that is equal to Kw. Accordingly, what is Kh? Kh is nothing but Kw by Ka. Substitute this expression in this particular case. So it is very easy to get pH that is equal to 14 minus, and I can write minus logarithm of, this can be substituted, Kw by Ka into C the whole power half. Is it clear? Yes, after this, the expansion is written as follows. Yes, the pH that is equal to 14 minus, you have noted that minus log of Kw by Ka into C the whole power half. This is the expression what we were written earlier. Now minus into minus, it becomes plus. pH that is equal to 14 plus, I can expand this as follows, log Kw power half plus log C power half and minus log of Ka power half. The Ka is in the denominator. So when it is taken to the numerator, it becomes minus log of Ka power half. And pH that is equal to 14 plus, we know the value for Kw. Kw is nothing but 10 power minus 14 ionic product of water. When you substitute that, log of 10 power minus 14 the whole power half plus log of C power half minus log of Ka power half. Then what happens? It becomes pH that is equal to 14 plus log of 10 power minus 14 is written as follows, minus 14 into log of 10 and 14 power half, this is becoming 7, minus 14 into power half, it is nothing but minus 7 into log 10 plus half log C and minus log of Ka. What is minus log of Ka? It is nothing but pKa. So in place of minus log of Ka, I can write half into pKa. Minus log of Ka is nothing but pKa. Actually the power half, and it is written as half into minus log of Ka, and that is replaced by pKa. Now we have got an expression like this, and we can say pH that is equal to 14 minus 7 into log 1. So it becomes minus 7. Why? Log of 10 is equal to 1. So 1 into minus 7, it becomes minus 7 plus half into log C plus half into pKa. Finally, we can say pH that is equal to 7 plus half into log C plus half into pKa. And in the initial stages, you have noted that the salt of stronger base and weaker acid is basic in nature. And moreover, its pH value is greater than 7. Yes, here it is very well proved that pH is equal to 7 plus some value. What is the value to be added? Half of log C plus half of pKa. Clearly indicates that pH value is greater than 7 and hence the solution is basic in nature. Very simple. Just at a glance, pH that is equal to 14 minus log of Kw by Ka into C power half, the whole power half. It is splitted and written 14 and minus into minus it becomes plus. Log Kw power half plus log C power half. Ka is in the denominator, it is taken to the numerator. And we are writing pH that is equal to 14 plus log of 10 power minus 14 the whole power half. Minus 14 the power half is nothing but minus 7. That minus 7 is written here. Minus 7 into log 10. And we know that the log 10 is nothing but 1. So it becomes 14 minus 7. 14 minus 7 is 7. Plus log of Kc plus half pKa. This is also an important step. Minus log of Ka is nothing but pKa. And finally, we were made a conclusion pH is greater than 7 because the solution is basic in its nature. Okay.